Hello everyone, in today's video we are discussing about conversion of DFA to regular expression. So this is the given DFA diagram, so we have to write a equation for this. So first we will write incoming state for each and every state. So these are our state Q0, Q1, Q3, Q2. We will start with the initial state, that is Q0. So for Q0 there is a start state always which is represented by empty state, that is epsilon. Then it is having Q1 which is sending one equation, so we'll say 1 into Q1, and also it from Q2 it is taking 0 value. This is also incoming, so we'll say 0 into Q2. So this is the equation 1. Next for Q1 we have only one incoming state from 0, so 0 into Q0. So this is equation 2. Next for Q2 we are having only one incoming state, that is 1 from Q0, 1 into Q0. So this is your equation 3. Next Q3 equation, so which is having the value of incoming state from 1 Q1 and Q2. So we'll say 0 into Q1 plus 1 into Q2, and also it is having 0 and 1 for itself. So we'll get 0 into Q3 plus 1 into Q3. This is has equation 4. So now we'll substitute equation 1. So equation 1 will substitute this Q0 is equal to epsilon plus 1 into Q1 plus 0 into Q2. So in place of Q1, Q2, we can substitute equation 2 and 3. So equation 2 and 3 substitute in one equation. So we'll get Q0 is equal to epsilon plus, in place of Q1 we are substituting 0 into Q0, and this one value as it is, plus in place of Q2 we are substituting 1 into Q0 and this 0 as it is. So we'll get epsilon plus, in this Q0 if we take common we'll get 0 1 1 0 as a equation. So this can be written in the form of Ardine's theorem, that is this is as R Q R P. So this value we can write it as R is equal to QP star. So we'll get Q0 is equal to epsilon into 0 1 1 0 whole closure. So this is the Q0 value. So this is as a equation 5 we can say. So now next, substituting equation 1. So this equation we can simplify has epsilon into anything is R closure only. So we'll get 0 into 1 plus 1 into 0 whole closure only. So this equation we can consider is a phi equation. Or else next we have to take equation 1. So 0 into Q0, in place of Q0 substitute equation 5 for Q0. So we'll get Q1 is equal to 0 into this value we have to substitute. So this value we substitute as 0 into 1 plus 1 0 whole closure. Next, this is equation 6. Next we have to substitute Q2 value, so that is 0 into Q0. Again substitute equation 5 for Q0. Again in place of Q0 value we have to substitute. So we'll get Q0 into 0 into this Q0 value we have got as 0 into 1 plus 1 into 0 whole closure. So this we have got for Q2 state. This is the final for Q2. Next, again we have to see the Q3 state, that is 0 into Q1 plus 1 into Q2 plus 0 into Q3 plus 1 into Q3. So this is the equation 4 we are substituting. So this value we have to substitute Q1 value, Q2 value, Q3 value. So we know Q1 value has, so from equation 6 and 5 substitute values. So we get Q3 is equals to 0 into Q1 value is 0 into 0 1 plus 1 0 whole closure plus this Q2 value we have got again. So 1 into Q2 value we have to place 7th equation, that is 0 into 0 1 plus 1 0 whole closure. In this we can take this Q3 as common, so we will get 0 plus 1 into Q3. So again this equation we can write in the form of Arden's theorem, that is R Q P. So this will be R. So this we can write in the form of Arden's theorem, that is R is equal to QP closure. So Q3 is equal to, so we get 0 into 0 0 1 plus 1 0 whole closure. So this is the Q value we have got. Next P value, so 1 into, so this is complete P value, so we get 0 into 1 plus 1 0 closure plus 0 plus 1 whole closure. So this is the final equation we have got.